Okay, hi everybody. We're back for 3132 part 2, and we were just going to kind of go through the unit circle a little bit. Okay, so again, this is just one right here, one unit, whether it's 1 yard, 1 foot, whatever. Okay, so first I want to talk about how much each of these angles are. Okay, we already kind of know that this is 90 degrees, right? We already know that once around is 360 degrees. What we also just saw was that once around is 2 pi. Right, what we know the circumference is 2 pi times the radius, right? 2 pi r. We just said the radius was 1. So 2 times pi times r, 2 times pi times 1 is just 2 pi. Okay, so I'm going to write the radian measure right beside the 360 degrees. Then another way to think of 360 degrees is 2 pi radian. Sorry, I don't have my pen. Okay, so 2 pi is this in radians is the same as 360 degrees. They represent the same amount. Okay, so if 2 pi is the whole way around, halfway around is half of 2 pi, right? Which would be pi. And we, of course, know that as 180 degrees. All right, so 180 degrees is the same as 2 pi, or as 1 pi. All right, so just what I want you to do is kind of get used to, just like we would for, I can say 1 foot or I can say 12 inches. It's the same amount, right? That's what's happening here. Okay, so this is 180 degrees is the same as pi radians. Okay, all right, so 180 degrees pi radians. Well, if 2 pi is the whole way around, pi is halfway around. Half of halfway around would be pi over 2, or 90 degrees. Okay, so 90 degrees is the same as pi over 2 radians. Some people think of it as half pi. Okay. All right, and then let's go even further. We did this a little bit. 45 degrees is the same as half, or half of pi, so that's pi over 4, or 1/4 pi. Okay, and of course we also have our the way that we just learned how to translate between one and the other. So if I want to do 30 degrees and I'm tired of thinking of it this way, I can take 30 times pi over 180. Okay, and I think of 30 degrees as, a third of the way to 90. So 1/3 of pi over 2 would be pi over 6. Well, that's what we're going to get here, right? 30 over 180, that's the same as 3/18 or 1/6 pi. So this is pi over 6. Okay, so if you don't like doing it the way I'm doing, just trying to section off the unit circle, you can certainly multiply by pi over 180 every single time. That will give you the radian measure. Okay, so 60 degrees, I can take 60 times pi over 180. That would be 60 over pi, 6/18. What's that, 1/3? 1/3 pi. We call that pi over 3. Okay, so what I'd like you to do is fill in the rest of the unit circle for homework. Okay, now you might see these ordered pairs over there, so I have to do that as well. But I want you to write in the degrees and the radian measure for each of these angles. Okay, realize each of these angles is starting, we're starting in standard position and we're opening that far. Okay, so there's your pi over 6, pi over 4, pi over 3, pi over 2. Okay, it's the same. We're starting at the positive x-axis and opening in the counterclockwise direction. Okay? All right, well, if this is 1 unit, then this point right here would be the point 1, 0. Right? Isn't that 1, 0? Okay, I'm just looking at the ordered pair. If I was going to plot it, that would be the point 1. I went over 1 and up 0. That's 360 degrees, goes with the XY point 1, 0. Okay? Now, 30 degrees, I'm going to go over. I'm trying to think. What did we say the sine of 30 degrees is? Think about this triangle. Okay, if I would drop a line right down here, okay, then I'd have this triangle. And if this is 30 degrees down here, okay, then the y coordinate is a half. The sine is a half. The cosine was square root of 3 over 2. Okay, so this point is square root of 3 over 2, comma, 1/2. That's this ordered pair that goes with 30 degrees or pi over 6 radians. Okay? The x coordinate is square root of 3 over 2. The y coordinate is a half. These are things that we have to memorize. Okay? The 45-degree angle, if I would make a triangle out of that, I'd have 45, 45, 90. Okay? And that's the one where the x and the y coordinate are the same. They're both square root of 2 over 2. So you have square root of 2 over 2, comma, square root of 2 over 2. I really wish I had my pen. Okay? Square root of 2 over 2 is x. Square root of 2 over 2 is y. 60 degrees. Again, if I would make my triangle here, then this would be 60 degrees down here. This little one would be 30. So this time my x coordinate is a half and my y coordinate is square root of 3 over 2. So I'm at a half square root of 3 over 2. Okay. And then this point right here, looks like I went 0 and then up 1, right? 0, 1 is that ordered pair. Okay. And we've had the quadrantal angles already. We've done those. Okay. But I wanted you to look at all these. That's everything that you need to know. You just need to translate that now to the other side of the circle where the x coordinates are negative, but the y coordinates are still positive. In other words, if I go straight over here, okay, to this angle, my x coordinate is negative square root of 3 over 2, and my y coordinate is still 1/2. Negative square root of 3 over 2, comma, 1/2 is what goes with this ordered pair. Okay, it's the same as the one on the other side, except negative x's. Okay, does that make sense? Down here, it's the same as well, except it has a negative x and a negative y. It's negative square root of 3 over 2, negative 1/2. Right? That's what that ordered pair is that goes right here. And here it is again, positive square root of 3 over 2, but negative 1/2. Okay, so I just was kind of showing you each of those. I want you to do the other ones. Relate it to where it is in the unit circle. Of course, this one is what? Negative 1, 0. If we go here to this one. Okay, that's what this ordered pair is, negative 1, 0. Okay. And the one down here would be 0, negative 1. Okay, and I also want you to put the degrees here. Okay, here I was 90 degrees, and then I go, what would this be? 120, 30 degrees more, right? 135, 150, 180, 210, okay, etc. Put the degrees, put the radians that go with it by multiplying by pi over 180, and put the ordered pairs. Okay, finish that unit circle, and we'll talk about it in class then. All right, but that's part of your homework is to finish this unit circle up. Okay, arc length we talked about. We already sort of saw that arc length equals radius times theta as long as theta is measured in radians. It doesn't work if theta is in degrees. You have to change your radians to degrees. And then if you want to know this arc length, just take whatever this radius is. Okay, now we're not on the unit circle anymore, so maybe this radius is 3. I'd have to take it 3 times whatever this is, pi over 3. Okay, and then the arc length would be pi. So the length of an arc intercepted on a circle of radius r by a central angle measured in radians is given by arc length equals radius times theta. Okay, so here, when we're asked to find the exact arc length, hey, that's not a problem. Arc length equals radius 7 times theta, 3 pi over 4. So my arc length is 21 pi over 4. Now, for me, when we're talking about a length, I sometimes like to get the approximation. So I might take 21 times pi and divide it by 4 and say it's 16.49. I'm going to say it's about 16 and a half. Okay, and then I look at it, I'm like, if this is 7, does it make sense that this distance is about 16 and a half? Okay, and it does to me. Okay, is that all right? This one, I can't do it. It's not measured in radians. I can't do it the way it is. I have to take my 200 degrees and change that into radians. Okay, I have to say, oh, well, that's actually 10 pi over 9 radians, right? If I multiply that by if I multiply 200 degrees by pi over 180, I get 10 pi over 9. Now I can tell you the arc length. It's 7 times 10 pi over 9, which would be 70 pi over 9. That's one way we could say, but again, since it's a distance, I might actually want to take 70 times pi and divide it by 9, just to give it an idea. That's 24.4, about 24 whatever feet or whatever this is. Okay, it didn't tell me what that was, but 24.4 is what I got for that. Okay, so if this is 7 and we just saw that was like 16, that would make sense. That's about 24. Okay, just make sure if it's given to you in degrees that you change it to radians first and then multiply by the radius. Okay, how many inches will the weight in this figure rise if the pulley is rotated through an angle of 71 degrees, 50 feet? Okay, so as we rotate it, you realize, this is going to be lifted however much this arc length is. Okay. Sorry, my computer decided to turn on for my printer. Okay, so I'm going to take 71 degrees, 50 minutes, and change that to radians. Okay, I might do that on my calculator. Okay, so we have, that turned out to be 1.25 about. I'm going to make that a squiggly line. 1.25. Okay, so I'm going to take 1.25. That's how many radian it is, times the 9.37. Okay, that's my theta times my radius. And I get 11.7. Yep, 11.7 inches. Okay. Through what angle must the pulley rotate to raise the weight 6 inches? Okay, so now I want the arc length to be 6. So I have 6, okay, arc length equals theta times the radius. So I'm going to take 6 divided by 9.37, and that gives me 0.64. But that's in radians. It's said to the nearest minute. So I'm going to have to take 0.64 times 180 over pi. Okay, and when I do that, sorry, it was 5 inches. So 5 equals theta times this. 5 divided by that is 0.53 times 180 over pi. You get 30 degrees, blah, blah, blah. You have to change it into minutes with your calculator. You should have gotten this. Okay, all right, Good luck with the rest of your assignment. Sorry, it ran out of time.